Welcome to class today. You've been doing such a good job and working hard, so I thought today I would reward you, and we're going to hit the slopes today. You're right, you're not going to need a snowboard, you're not going to need skis, you're going to need a little bit of math. So slope is a mathematical way to describe how steep something is. So take this mountain for example. If I asked you how steep this mountain is, how would you describe that to me? You might be thinking very steep, or kind of steep, or a little bit steep. Whatever words you use, it still doesn't really become clear about how steep it is. Even if we draw a line, and I see a line there now, but it still is hard to really describe how steep something is. And that's where slope comes in handy, because slope is a specific way, or clear way, to describe really how steep something is. Looking at the connection between steepness and slope. Here's an example of another mountain. We're going to use your imagination. Pretend this is another mountain with the original in the background. Would you say that this example is more steep or less steep than the original? Good, it's more steep. And we're going to draw this red line to show that it is more steep. Now a second example. Is this more or less steep than the original? Good, it's less steep. And again, we can draw a red line to show how steep that is. To use the word slope, it is pretty similar to the word steep. And so I asked you, is this more or less steep? But I could also ask you, does it have a higher or lower slope than the original? How would you answer that? Does it have a higher or lower slope than the original mountain in the background? Right, it has a higher slope. What about this one? Does it have a higher or lower slope than the original? Good, it has a lower slope. And so when you say something is more steep, that means it has a higher slope. When something is less steep, it has a lower slope. And that's the connection. So they're not exactly the same word, but they have pretty similar meanings. The nice part about slope though, we can actually assign numbers to it and get more specific. And that's what we're going to do next. Look at these four lines. There's a specific order to them from left to right. What do you notice about their steepness or their slope from left to right? That's right. They are getting more steep or having higher slopes as you go left to right. And we talked about how you can have specific numbers for slope. So I'm going to give you two of the slopes. This line is 0.5. This line is 1.9. With those as your guide, I'm going to ask you to calculate or estimate these two slopes of the second and the fourth lines. And again, just an estimation, but I want you to tell me approximately what would the slope of this line be and what would the slope of that line be. So you'll need to get two numbers. I'll give you about 15 seconds to estimate this slope and this slope. Ready, go. About 5 more seconds. You got it? All right. So the slope of this line is actually 1. But remember, I only asked you to estimate. And so when you got your estimate, if it was between 0.5 and 1.9, you're on the right track. What about that line over there? What did you estimate? The answer is 3.2. But since you only had to estimate, if you picked any number that was bigger than 1.9, you would be right, because it is simply more steep than 1.9. Now we've had a chance to estimate and kind of see how slope can increase as it gets more steep. We're going to look specifically at where these numbers come from, because as you may already know or may have guessed, these numbers are not randomly assigned. They can be calculated for every line. This line right here has a specific slope, but there are two things we have to know in order to calculate the slope of this line to describe exactly how steep it is. You have to know the vertical distance or vertical change and the horizontal distance or horizontal change. As you look at it, the vertical distance is 3 units and the horizontal distance is 2 units. with those two pieces of information, I can calculate the exact slope of the line. The way I do that is a simple division. I'm going to first take the vertical distance of 3, and then I will divide by the horizontal distance of 2. Another way that people can describe this is how far up and how far over. So you take 3 divided by 2, and if you wanted to leave your answer as a fraction, you would have your slope of 3/2, or 3 over 2. If you actually divide, you would get your slope of 1.5. So we have our answer in fraction form and in decimal form. That's the process of calculating slope. So as long as you have your vertical distance and horizontal distance, you can calculate the slope of any line. Now I'm going to give you a chance with some pieces of information to calculate the slope of a line. The first question you have to ask yourself is, if I'm trying to find the slope of this gray line, do we have enough information to calculate the slope of the line? Yes or no? Yes, we do. We have the vertical distance and the horizontal distance. I'm going to give you about 1 minute, and I'm going to have you calculate the slope both in fraction form and in decimal form. So when I say go, calculate the slope of this gray line. Ready? Go. And this is where I would give them a full minute to actually calculate the slope in both forms, and then we would look at the answer and see if they got on the right track. All right, about 5 seconds left. And it's time to check your answer. So, which number do we use first? Do we start with? That's right, the vertical distance. That would be 3 in this problem. And then we divide by the horizontal distance, or 4. So that's your answer in fraction form. It's 3/4. In decimal form, what is it? Good, 0.75. Those are the ways that we calculate slope for any line. Take the vertical distance divided by horizontal distance, and that'll tell you exactly how steep something is, so you don't have to just say kind of steep or really steep. You can say, oh, its slope is 0.75 or 3/4. Good job.